Hi, everyone. Um, Welcome to the Snack and Learn webinar. Today, I'm Kelvin Chen, working in the Hong Kong office of WSP, and I'm a civil and geotechnical engineer, now working in the infrastructure team, focusing on geotechnical aspects and also project management of a few engineering projects in Hong Kong. So, together with me here is Dr. Dino Chen. And Dino is my colleague in WSP Hong Kong office, and he is a structural engineer with expertise in tall building design. Dino is also interested in digital development in engineering, including BIM, programming, and software development. So our presentation today will be divided into two parts. Um, in the first part, Dino will introduce the ETE OpenBIM OpenGIS solutions for slope, of which the development is led by him. There are several modules in this ETE OpenBIM OpenGIS solutions, which are the GI inventory, the Topo inventory, the slope inventory, and also the slope analysis automation tool. And then in the part two, I will introduce our recent experience in LiDAR scanning using a portable LiDAR scanner. A case study will also be shared. And in the end, there will be a Q&A session. So in Hong Kong, Hong Kong has a very hilly terrain, and much population is living on or near the slopes. And due to a few severe fatal landslides in the early 1970s, our government has set up the Geotechnical Engineering Office in 1977, focusing on slope management. Now Hong Kong has about 60,000 registered man-made slopes, and every year more than 100 substandard slopes registered will be studied and upgraded. Also, we often have a site formation works at hilly areas due to the hilly terrain in Hong Kong, and these involve slope works as well. So therefore, slope designs is a major task for geotechnical engineers in Hong Kong, and it is sensible that we would develop or adopt some tools to facilitate our work. And in the following, I will pass to Dino for part one sharing. Thank you, Dino.
Thank you, Kelvin. So I just introduced several tools we developed for our slope analysis and design. And this part will introduce some traditional way what we will do in the slope project. For example, I pay a lot of time and effort on the 2D drawing, collect the data information for the slope, and sometimes we just borrow or download some information from the original drawing from the government website, and then we pay a lot of manual effort to draw the plan and section. And for some slope strengthening scheme, we need to run some analysis program, and also this program also needs some manual input. So in the whole process, from the survey and design and some strength scheme study, we pay a lot of time on modeling and drafting. So we developed some tool for the engineer to use to improve the procedure or improve the productivity of the slope design and analysis. We develop in this PowerPoint we introduced four tools. One is GI Inventory, and is for the collect the GI data from the government website or the open data platform. And the other one is Topo Inventory to collect the data, 3D data for the slope for the terrain. And we have the slope inventory is for because Hong Kong has a lot of database for the registered slope site, so we can collect a lot of boundary from the data open data platform, and we can use this boundary cooperate with the Topo inventory. We can create the 3D Topo model for the slope. And finally, when we have the BI model, we can generate the section from the 3D model, can directly input to the automation software. So we call it, this one is we apply a lot of OpenBIM technology and the database technology to build this several inventory for the slope topo and the GI data. And then we transform the 3D surface data to the OpenBIM model or the native BIM model. And the first part, I will introduce some GI inventory. In the traditional way, we need to collect the GI report from the government website or from the contractor, and then do a lot of desktop study. So we can form the database and form the Excel table to generate to prepare the data for the draftsman to draw the borehole data or the borehole stick diagram. And nowadays we develop this inventory. We just this inventory just download the information from the open data platform provided by the Hong Kong government, and then we transform to the database attribute, and then we generate the drawing and the B model directly. And also they collect a lot of data from the GI data from the open data platform. And this part we can generate the B model for our further modeling or the slope analysis model. Also, this one is very useful for the foundation design. In topo inventory and slope inventory, the same thing in the inventory development is collect the 3D LiDAR data from the government website, and then you can use this topo inventory platform to generate the topo 3D surface in BIM format. And also you can input to the CO3D, AutoCAD, and the Revit BIM software. And with the boundary, this is this page. We know all the boundary of the registered slope site, so we can generate the 3D model of all the slope. So combined with the topo inventory, we can generate the 3D BI model for the slope. And when we get the BI model, we can assign some cut section line for the slope, and then we can generate a lot of series of the section, including the slope property, the soil property, and the rock property, and then we can generate the analysis model. This is the direct import to the software we call the GeoStudio Slope W, and then we use this software to run the slope analysis. Sometimes we run some soil nail or the slope strengthening scheme. And we can see some video demo for how we can use the software ETE GI Inventory and the slope inventory to accelerate the productivity for our slope analysis or the data collection job. Sorry. Yeah. And this is the graphic user interface of the software. You just need to select some area you concern, and then the program will generate the steep borehole diagram automatically. And the slope inventory, when we know the location of the slope, and then we just select the zone and then pick the slope we want to generate the BI model, and then the mesh is auto by the program, so we can generate the 3D model of the slope. So this tool we developed to reduce the manpower for the slope design and analysis. The next part is the LiDAR scanning. I pass to Kelvin.
Thank you, Dino. So in the next part two, I will talk about our recent experience in LiDAR scanning. Um, Before doing a slope design, we need to do some depth study, and one of the most important data we need is the topographic data. So traditionally, the topographic survey is done by the subcontractor, However, the process of this takes some time, as there are several stages, such as the tendering, and then the site work, which is the site survey, and then reviewing the subcontractors' deliverables, etc., before we get the finalized data. So earlier this year, we have purchased a portable LiDAR scanner, which allow us to generate a point cloud quickly and accurately for both indoor and outdoor environment. The scanner uses the SLAM method, which is the simultaneous localization and mapping, to map the surrounding environment, and its accuracy can be up to 2 centimeters. It could be used via handheld or backpack option with RTK and colorization additional modules. We have used this scanner to try different tasks, including surface extraction and also the tree segmentation, which the data obtained can be used to facilitate the slope design. It's still in a trial stage, but I would like to share some of our findings from the trial. So in a point cloud model, um, each point can be classified as ground points or above ground points. By selecting only the ground points, we can obtain the ground surface model and then generate high resolution surface like the DSM or the DEM models. The application of this is that we can cut cross sections easily from the surface model generated, which facilitates building the models for subsequent slope stability analysis. In the picture on the left, it is a point cloud model, and you can see that there are some brown points there. And these brown points are the uh, are the ground points identified by the software. And then the picture on the right, it shows the difference um, between before and after taking out the ground, the above ground points. So that means that the bottom picture is the one which shows only the ground points, and it is the ground surface that we need for the slope stability analysis. Um, the scanner package also has functions to segment individual trees and then generate information of the trees, such as the coordinates, the tree height, and the crown size. Um, this can help to verify the data obtained from tree surveys. However, the confidence level of this application or of this use case is still low because the segmentation algorithm is still under R&D. We tried that this tree segmentation function. It works in areas with scarce trees, but not in a dense vegetation. But with the rapid advancement of technology, I believe that we'll be able to experience a better version in the near future. So the left picture here shows a raw point cloud that we did with dense vegetation. So you can see that this tree segmentation results is not that good. On the right hand side, where trees are scarce, it actually gives a quite good results. So for the surface extraction, we actually try to scan real slopes on site. We selected two slopes, which are shown here, the BC14 on the left and the BC15 on the right. So to ensure this quality of the scanning, we try to plan closed slope scanning path to ensure that the whole slopes will be covered. Moreover, we make sure that the scanning is accurately located by setting a few ground control points. From this scanning trial, we found that the LiDAR scanning without scanner has some limitations. For the slope BC14, which is the picture on the left, the scanning results is not satisfactory. It's likely because it has more vegetation and the slope surface is more irregular as it has some rock outcrops. Also, some parts of the slope can only be accessed from one side, and therefore a closed loop scanning path cannot be performed. On the other hand, the scanning of slope BC15 gave a much better results. Comparing to the slope BC14, it has less vegetation and a smoother slope surface. And also a closed loop scanning path can be performed for this slope. So these are the scanning results of the slope BC15. Um, at the upper left corner, it is the post-process point cloud, which has been colorized and georeferenced. And then at the bottom left, it is a classified point cloud, which differentiate the ground points and also the man-made features or the above ground points. For the picture on the right, it is the surface contour we generated from our model, and it is found that it pretty much matches with the government's data. So to conclude, from our first part of presentation shared by Dino, the GI inventory utilizes open data to collect existing geotechnical information, which is the ground investigation data near the project site. This saves engineers time in searching for data. The CAD drawings generated by the GI inventory can also be directly used for the project and thus reducing the drafting time. For the slope inventory, it can extract 3D models of slopes near the project site from the open data, allowing for the direct generation of an OpenBIM model and therefore saving much modeling time. And in addition, the slope design automation tool can generate the models required for calculations, and this further reducing the time that the engineers need to use for analysis. And for the LiDAR scanning part, using the portable LiDAR scanner can definitely save time for obtaining topographic data for slope design, comparing to the traditional approach. And as the technology is advancing rapidly, we expect that more functions can be performed by this kind of portable equipment and tool, such as the tree segmentation that I mentioned uh, in the above slide. So that's all for our sharing today. So next, it will be the Q&A section. Yeah, thank you.
Thank you, Kelvin. Thank you, Dino. Fantastic presentation. Thank you for sharing with us these really exciting technologies. Please continue to log your questions in the question box on the control panel. And I will start with the first question. You mentioned the time can be saved using the LiDAR scanner. Can you elaborate more how much can be saved in a project?
Yes. So traditionally, as I mentioned in the presentation, we need to engage a subcontractor to do a topographic survey for us. So first, we need to prepare the tender documents and then send out invitations, and then tenderers return their quotations to us. And after that, after we receive the quotations, we will then assess their quotations. And this tendering process would take normally at least 3 weeks. Yeah, from our experience. And then after the subcontractor is selected, it takes about a week for them to arrange resources and carry out the site work, as well as preparing the draft deliverable, um, which is the topographic plan. Um, Here I'm just talking about a slope with size like the one I shown in the slide. Yeah. So after we receive the draft deliverable, um, usually there will be 1 or 2 rounds of comments and revision until the topographic plan can be finalized. And usually this would take around another 2 week time. Yeah. So on the other hand, if we use the LiDAR scanner ourselves, um, we just need about 2 to 3 days to prepare and then carry out the site work. And then for the processing of the point cloud data, such as the coloring, filtering, generating the contours, etc., it takes about 1 week time. So uh, if just counting the time from the site work to the topographic plan being finalized, um, it's expected that around 1.5 week can be saved for a slope with a scale similar to that in our case study. Yeah.
Thank you. Another question about the LiDAR scanning. How long does it take to scan a slope? And is there any specific points to note when doing site work?
And for the slopes in our case study, say the BC15, the plan area is about, it's not a large slope. The plan area is only about 600 meters square. So with a maximum height of 12 meters. So this took us about 30 minutes to complete the scanning. The BC14 is a bit smaller, so we took only about 20 minutes to scan it. Um, one thing to supplement, the LiDAR scanner we purchased comes with 2 batteries, and each battery can last for about 2 hours. So if we are going to scan a large area, then we may need to do that um, in a few days separately, or we have to get more batteries. And then for the second part of the question about is any special points to note, there's nothing really special to do the scanning work. I think just to make sure that the camera and the RTK is on before scanning around. Of course, safety is always the highest priority. So we always send at least 2 people to go together, yeah, for the scanning work. Yeah, thank you.
Thank you. A question for you, Dino. Why not use GIS software and instead develop an inventory software?
Yeah, and for why the purpose we developed some ETE software to produce some giant data or the Topo inventory and the slope inventory, because we for GIS software sometimes we need pay a lot of time to learn how to use these GIS softwares. For example, like RGS, and but sometimes we just want to use a little bit function of this GIS software. For example, we just need to locate some location or the point georeference data, and then we don't want the engineer to pay a lot of time to learning the new software and just use a little bit function. So we just design a software which one is focused on some, for example, GI data and the slope inventory, this function. So the engineer just need to, for example, like uh, look at the main menu, user menu, and use less time to study this software, and they can know how to use and can generate drawing from the software directly. For GIS, it's very difficult to connect GIS software to Revit or BI model. So we develop another technical part in our software is can use our software to get the data from the data platform, open data platform, and generate the drawing and CAD drawing and the BIM model directly from our software. This one is much advanced than the GIS software. If you pay some time on the second development of the GIS, also can do this part of the work, but it's very difficult to use the raw software like GIS software. Yeah.
Thank you. What are the challenges of applying BIM in slope design?
Oh, this is quite a big challenge because in most of our project, we use BIM model. It's not like CLVD because we need to communicate with the MEP team and the other team. So most of the building project or the slope project, we still need to use the Revit model. So for the Revit model, the Revit software, Excel is designed for the building only. Nowadays, we need to use Revit, this building software, to apply to the infrastructure design, like a slope design. So in the Revit, we need to develop a lot of family or the plugin, especially for the infrastructure. So that's a quite lot of challenge. So in this one, in the infrastructure, we develop some plugin and some tool for the civil job. Also, we also need to use OpenBIM for another choice because most of the project, they have some requirement to have a further development. For example, you need to use this project as the BIM model. We need to make sure this model will last more than 50 years or 100 years for infrastructure. So we need to keep on to update the OpenBIM model. So in our R&D work, we decide the slope inventory, we can directly generate the OpenBIM model from the open data platform. So it's useful for that one. That's quite challenging for the CEO job. We need to develop our new technology on the building BIM software like Revit. Yeah.
Thank you. I will take the last question, and all additional questions will be answered directly by the presenters. Can slope automation be used with Plaxis?
Yes, but nowadays the software is for the slope W from the Geo Studio. It's a common software for the slope stability analysis in Hong Kong. But from my understanding, the other country or the other region, they use Plaxis 2D or Plaxis 3D to run the slope analysis. I think it's quite easy because the Plaxis have the Python SDK tool, so you can develop some Python code, you can generate the model. So we can use our slope automation to generate the data to use the Python script to transform the model, the Geo Slope W model to be a Plaxis model. It can be done. Yeah.
Thank you, Dino. Thank you, Kelvin, for a fantastic presentation. And thank you, everyone, for joining us today. We appreciate it. I appreciate your time. And thank you, the presenters, for staying so long in their day. Have a good evening. And you can reach out to them via the contact details shown on the screen. So again, thanks, everyone. We will wrap up the session now. Thank you.
Bye.